Okay, imagine this. You're building a cutting-edge AI application, but you don't want to be tied to big tech,
Mm-hmm.
at their whims. And
Yeah.
that's where the open source AI stack comes in.
Yeah.
It's like having the keys to the AI kingdom, giving you that control,
Yeah.
that flexibility, and frankly,
Yeah.
a whole lot of fun along the way.
Right.
So today,
Mm-hmm.
we're going to deep dive into this world,
Yeah.
exploring how it works, the cool tech behind it,
Mm-hmm.
and how you can use it to build amazing things.
It's like switching from a prepackaged software suite
Right.
to a powerful set of individual tools
Yeah.
that you can assemble and customize however you like.
Yeah, exactly. We'll break down the essential components
Mm-hmm.
from those brainy LLMs to the clever tools that make them tick,
Yeah.
and even get into some code examples so you can see how it all comes together.
Sounds good.
You ready to get technical?
Absolutely. Let's start by understanding why open source AI has gained so much traction. You see, the early days of the AI revolution were dominated by proprietary models,
Right.
which came with a few drawbacks:
Yeah.
high costs, limited control over your data,
Yeah.
and getting locked into specific vendors.
Right.
Those were major concerns for many developers.
Yeah, those were some serious roadblocks.
Yeah.
But the open source movement came to the rescue,
Yeah,
offering a way to break free from those limitations.
exactly. Open source AI brings control, flexibility, and cost-effectiveness back to the table.
Okay.
You get to choose the tools that best fit your needs,
Right.
deploy them wherever you want,
Yeah.
and keep your data safe and sound.
Sounds like a dream for developers.
It is.
Now let's get to the heart of it all. LLMs.
All right.
These large language models,
Mm-hmm.
they're the brains behind many AI applications.
Yeah.
And the open source options,
Yeah.
they're becoming increasingly impressive.
They're starting to rival their proprietary counterparts in terms of performance.
Wow.
But with the added benefits of transparency and customizability.
We're talking about models like Llama 3.3 from Meta,
Yep.
the Mistral family,
Uh-huh.
Alibaba's Quinn 2.5,
Mm-hmm.
Microsoft's Phi 3,
Yep.
and even DeepMind's Gemma 2.
Right.
It's a pretty exciting lineup,
It is.
and they're all open for you to explore and experiment with.
What's really exciting is that you're not limited to using these models as they are.
Okay?
You can fine-tune them on your own data,
Right.
adapt them to specific tasks,
Well,
and even contribute to their development.
so it's like having access to the source code of an amazing piece of software, giving you the power to understand how it works
Right.
and make it even better.
Exactly. Now, while LLMs are powerful on their own,
Okay.
they often work best in combination with other tools
Yeah.
like embedding models.
Okay.
These models are crucial for tasks like semantic search
Huh?
and what's called retrieval augmented generation,
Right.
or AGI for short.
RAG sounds like a friendly acronym
Yeah.
for something so powerful.
Mm.
So what are embedding models all about?
Yeah.
And how do they work with LLMs?
Imagine you have a massive database of text, documents, articles, code, anything you can think of.
Mm-hmm.
Embedding models take those chunks of text
Right.
and convert them into numerical vectors
Right.
that capture their meaning.
Okay.
Think of it like giving each piece of text
Yeah.
a unique fingerprint based on its content.
Okay, so it's like taking those complex ideas
Yeah.
and translating them into a language that computers can easily understand and compare.
Precisely. And once you have these vector representations,
Okay.
you can do some really cool things.
Mm-hmm.
For example, you can compare the vectors of different pieces of text
Okay.
to see how similar they are.
Gotcha.
This is the foundation of semantic search.
Right.
Instead of just matching keywords,
Yeah.
you're searching based on meaning.
So I could search for a concept or an idea,
Mm-hmm.
and the system would find the most relevant documents, even if they don't use the exact same words.
Yeah.
That's incredibly powerful.
Mm-hmm.
What are some popular open source embedding models that developers can use?
There are quite a few. Some popular choices include the sentence transformers family,
Okay.
often called SBERT,
Mhm.
which are known for their high-quality sentence embeddings.
Right.
There's also Nomic Embed Text, V1.5,
Okay.
BGE from BAAI,
Mm-hmm.
and Gina AI's Gina Embeddings V3,
Okay.
each with its own strengths and areas of expertise.
It's like having a toolbox
Yeah,
full of specialized tools for extracting meaning from text.
exactly.
Now let's get down to the practical side of things.
Mm-hmm.
We've talked about these amazing LLMs and embedding models,
Yeah.
but how do we actually deploy and manage them?
Right.
That's where things can get tricky, right?
You're right. Managing these models can be a challenge, especially if you're dealing with complex infrastructure and dependencies.
Mm-hmm.
But there's a fantastic open source tool that simplifies the entire process.
Okay.
Alama.
Olama like the animal.
Yep, just as resilient and sure-footed.
I like it. Olama allows you to run both open source LLMs and embedding models
Okay.
with incredible ease.
All right.
You can deploy sophisticated models with a single command,
Oh, wow.
abstracting away all the infrastructure complexities.
So it's like having a personal AI assistant that handles all the setup and management,
Right.
letting you focus on building your application.
Exactly. It streamlines the entire workflow,
Okay.
making it incredibly easy to experiment with different models
Right.
and integrate them into your projects.
That's a game changer for developers who want to focus on the creative side of AI
Yeah,
without getting bogged down in infrastructure headaches.
absolutely. And speaking of infrastructure, let's not forget about the data itself.
Okay.
We need a robust and efficient way to store all this information
Yeah.
that our AI models are going to be working with,
Mm-hmm.
including those vector embeddings we talked about.
And this is where databases come into play, right?
That's right.
But traditional databases weren't really designed to handle the unique challenges of AI data.
Were they?
That's true.
Yeah.
But thankfully, we have PostgreSQL,
Oh,
the trusty workhorse of the database world.
right. The good old standby.
Mm-hmm.
But,
And it's gotten even better with some amazing extensions,
okay.
specifically designed for AI application.
PostgreSQL, the good old standby, but with some new tricks up its sleeve. What are these extensions all about?
Well, there's PG Vector,
Okay.
which allows you to store and query vector embeddings directly within PostgreSQL.
Okay.
It's like having a specialized data type just for those numerical fingerprints of meaning.
So we can treat vector embeddings as first-class citizens in our database,
Exactly.
just like any other data type.
Exactly. And PG Vector comes with built-in functions for calculating distances between vectors,
Wow.
making it incredibly efficient to perform similarity searches.
So we can find the most similar items in our database based on their meaning,
Right.
even if they don't share any keywords.
Exactly.
That's incredible.
It is. And PG Vector makes these similarity searches incredibly efficient, even on massive data sets.
Yeah.
Then there's PG Vector Scale,
Mm-hmm.
which enhances PG Vector's capabilities
Right.
for handling even larger data sets and more complex queries.
So we've got the power and scalability to handle those massive AI data sets. But how do we actually integrate these LLMs and embedding models into our data workflows?
That's where PGUI comes in.
Okay.
This extension provides a seamless way to use LLMs and embedding models within your SQL queries,
Mm-hmm.
making it incredibly easy to leverage AI within your existing data infrastructure.
So instead of having separate systems for your database and your AI models,
Mm-hmm.
you can keep everything together in PostgreSQL,
Exactly.
making your applications more efficient and easier to manage.
Precisely. And PGUI even has a feature called PGUI Vectorizer
Okay.
that simplifies the process of creating and managing embeddings,
Okay.
making it as easy as working with traditional database indexes.
It's like PostgreSQL has transformed into a powerful AI-ready database platform.
It really has. And with these extensions, you can build sophisticated AI applications that leverage the full power of both structured and unstructured data.
This is all starting to come together beautifully.
It is.
We have our LLMs and embedding models handled by Olama
Yeah.
and PostgreSQL with its extensions to store and manage all the data.
Uh-huh.
What comes next in building an open source AI application?
Well, we need a way to connect all of this intelligence to our users.
Right.
And that's where the back end and front end come into play.
Okay.
We'll get into those next. But first,
Yeah.
let's take a closer look at some of the key data structures and formats
Yeah,
involved in working with this open source AI stack.
Okay, let's roll up our sleeves and get ready for some code.
When you're building AI applications, especially with the open source stack,
Mm-hmm.
understanding the underlying data structures is crucial.
Right.
It's like knowing the grammar of a language.
Okay.
It allows you to communicate effectively and build more sophisticated structures.
That makes sense. So what are some of the key data structures that developers need to wrap their heads around?
Well, we've already talked about vector embeddings,
Right.
which are essentially arrays of numbers
Okay.
that represent the meaning of text.
Right.
You'll often encounter these embeddings as NumPy arrays in Python.
Mm-hmm.
where each element in the array corresponds to a specific dimension of the embedding space.
Okay, so if I were to print out a vector embedding, I'd see a series of numbers, something like 0.25, 9.87, 1.12, and so on, right?
Exactly. The length of this array,
Sure.
the number of dimensions, depends on the embedding model you're using.
Right.
Some models might produce embeddings with hundreds of dimensions,
Mm-hmm.
while others might have thousands.
Wow, that's a lot of numbers to represent the meaning of a single piece of text.
It is. But the beauty of it is that these numerical representations
Yeah.
allow us to compare the meanings of different pieces of text
Okay.
in a very precise and efficient way.
So we can calculate the distance between
Mhm.
these vectors
Mm-hmm.
to see how similar or different the meanings are.
Precisely. And there are different ways to measure distance,
Okay.
each with its own pros and cons.
Right.
Euclidean distance, cosine similarity, and dot product are some common measures used in AI applications.
It's like having different rulers for measuring the semantic space. Now, besides vector embeddings, what other data structures are important in this world?
Well, when working with LLMs,
Okay.
you'll often be dealing with text data in various forms.
Right.
You might have raw text strings,
Mhm.
lists of words or tokens,
Wow.
or even more structured representations like JSON objects that contain text fields.
So it's like having different containers for holding and organizing our text data,
Yeah.
depending on the specific task.
That's a great analogy. Choosing the right data structure
Yep.
can make it much easier to process, analyze, and manipulate your text data.
Mm-hmm.
For example, if you're working with a large corpus of text,
Right.
you might want to tokenize it first, breaking it down into individual words or subword units.
That makes sense. Tokenization helps the LLM understand the structure of the text and process it more efficiently, right?
Exactly. And once you have your text data in a suitable format,
Good.
you can use the Hugging Face Transformers library
Right.
to feed it into your LLM
Mm-hmm.
for tasks like text generation,
Yeah.
summarization, or translation.
So it's like preparing the ingredients before cooking a delicious AI meal.
I like that analogy. Now let's talk about where we store all this databases.
Okay.
We've already touched upon PostgreSQL and its fantastic extensions for AI,
Right.
but let's dive a bit deeper into how we actually use them to manage our AI-related data.
Okay. Let's get into the nitty-gritty of database management.
PostgreSQL is a relational database, which means it's great for storing structured data in tables with rows and columns.
Okay.
You can use it to store things like user profiles,
Yes.
product information, or any other data that fits neatly into that tabular format.
That's the traditional way of using databases. But what about the more unconventional data we encounter in AI, like those vector embeddings we've been talking about?
That's where the PG vector extension comes to the rescue.
Okay.
It allows us to store vector embeddings directly within PostgreSQL as a special data type.
So PostgreSQL now recognizes these numerical fingerprints of meaning as a distinct data type
Exactly.
with special properties and functions.
Exactly. And this opens up some amazing possibilities.
Okay.
For example,
Yeah.
we can use PG vectors' built-in functions to calculate the distance between two vectors,
Mm-hmm.
which is essential for tasks like semantic search.
So we can find the most similar items in our database based on their meaning, even if they don't share any keywords.
Exactly.
That's incredible.
It is. And PG vector makes these similarity searches incredibly efficient,
Right.
even on massive data sets.
Yeah.
Then there's PG vector scale,
Right.
which extends PG vector's capabilities
Okay.
for even larger data sets and more complex queries.
So we've got the power and scalability to handle those massive AI data sets. But what if we're working with unstructured data, like raw text or documents?
PostgreSQL can handle that too.
Okay.
It has excellent support for storing and querying unstructured data using text-based data types
So
and full-text search capabilities.
we can keep all our data, both structured and unstructured, together in PostgreSQL, making our applications more efficient and easier to manage.
Exactly. And the PGI extension makes it incredibly easy to integrate your LLMs and embedding models
Right.
into these data workflows,
Okay.
allowing you to leverage AI directly within your SQL queries.
This is starting to sound like a data management dream for AI developers.
It really is.
Oh.
And it gets even better when we start talking about data versioning.
Versioning, like keeping track of different versions of a document or a piece of code.
Exactly. But in the context of AI,
Okay.
data versioning takes on a whole new level of importance.
Right.
You see, AI models are often trained on massive data sets, and those data sets can change over time.
So if our training data changes, our models might need to be retrained to reflect those changes.
Exactly.
But if we don't properly track those changes,
Yeah,
things can get messy, right?
absolutely. Without proper data versioning,
Yeah.
we risk losing track of which data was used to train which model,
Mm-hmm.
making it difficult to reproduce results
Right.
or understand how our models have evolved.
Right.
It's like trying to bake a cake without knowing which ingredients you used or how much you added of each.
That sounds like a recipe for disaster.
Mhm.
So how do we avoid this data versioning nightmare?
Thankfully, we have some amazing tools for data versioning in the open source world.
Yep.
DVC,
Hmm.
Git LFS,
Okay.
and MLflow are some popular choices,
Excellent.
each with its own strengths and approaches.
And these tools help us keep track of different versions of our data sets,
Yeah,
allowing us to go back in time and see exactly what data was used to train a particular model.
precisely. They provide a clear and organized way to manage your data,
Yep.
ensuring that your AI experiments are reproducible
Right.
and your models are trained on the right data.
That's essential for building robust and reliable AI applications.
Huh.
Now, besides versioning, what other data management challenges do developers face?
One crucial aspect is data preprocessing.
Okay.
Raw data is often messy and inconsistent,
Right.
which can cause problems for our models.
So it's like cleaning and preparing our data before serving it to our AI models.
Exactly. Data preprocessing involves tasks like cleaning up missing values,
Mm-hmm.
handling outliers,
Okay.
and transforming data into a format our models can understand. It's like taking those raw ingredients
Right.
and chopping, slicing, and dicing them into the right shapes and sizes for our AI recipe.
Love the analogy.
Yeah.
So what are some common techniques for data preprocessing in the open source world?
Well, there are libraries like Pandas and scikit-learn
Okay.
that provide a wide range of preprocessing functions.
Pandas, I've heard of that. It's a Python library for data analysis and manipulation. Right?
You got it. And scikit-learn is a machine learning library
Okay.
that also includes many useful preprocessing tools with
Yeah.
these libraries.
Yeah.
We can fill in missing values,
Right.
standardize our data,
Mm-hmm.
or convert categorical variables into numerical ones.
So we're essentially making our data more palatable for our AI models.
Exactly. And for text data,
Okay.
there are specialized libraries like NLTK and Spacey
Okay.
that provide tools for tokenization,
Mm-hmm.
stemming
Right.
lemmatization,
Okay.
and part of speech tagging.
Ah, yes, NLTK and Spacey. Those are the natural language processing powerhouses.
They are. They help us break down text into smaller units,
Yeah.
extract meaningful information from it,
Yeah.
and prepare it for use with our LLMs or other AI models.
It's amazing to think that all of these data manipulation and pre-processing tasks can be done with open source libraries and tools.
It is. And these libraries are constantly evolving,
Right.
thanks to the contributions of a vibrant open source community.
So we've covered data structures, databases, versioning, and pre-processing. What else do developers need to know to become data wizards in the open source AI world?
Well, another important consideration is understanding the different storage formats for AI data.
Okay.
Choosing the right format can significantly impact the efficiency of your AI workflows.
Storage formats like how we save our data to disk so we can access it later.
Exactly. And when it comes to AI,
Yeah.
we often deal with large data sets that require efficient storage and retrieval.
Right.
It's like choosing the right containers for storing our ingredients. Some containers are better suited for certain types of ingredients than others.
So it's not just about saving the data.
Yeah.
It's about saving it in a way that's optimized for our AI recipes.
Mm-hmm.
What are some of the popular storage formats for AI data?
Well, there's the classic CSV,
Mm-hmm.
which stands for comma-separated values.
Right.
It's simple and easy to work with,
Yeah.
but it can be inefficient for large data sets.
Okay.
Then there's JSON,
Mhm.
the JavaScript object notation, which is great for representing complex data structures
Right.
and is commonly used for unstructured data like text.
Okay. Those are the familiar ones.
Yeah.
What about some more specialized formats?
For large data sets and analytical queries,
Okay.
columnar storage formats like Parquet and Avro are often preferred.
Columnar storage. What's so special about that?
Instead of storing data row by row,
Oh,
like
sure.
CSV or JSON,
Mm-hmm.
columnar formats store data by columns.
Okay.
This is much more efficient for analytical queries,
Right.
which are common in AI workflows,
Mm-hmm.
as it allows us to read only the columns we need,
Right.
rather than entire rows.
Ah, that makes sense. It's like having our ingredients organized in separate containers
Exactly.
so we can quickly grab what we need without having to sift through everything.
Exactly. Columnar storage also allows for better compression and data partitioning,
Okay.
making it ideal for large-scale AI applications.
So it's like having a well-organized pantry for our AI data, making it easy to find what we need quickly and efficiently. Now let's move on to the bridges that connect our code to all these powerful AI models and libraries,
Yeah.
the APIs.
APIs are essential for interacting with these tools.
Right.
They define the rules and conventions for communication,
I see.
allowing us to send data, receive results,
Right.
and control their behavior.
Okay.
It's like having a set of instructions for talking to our AI companions.
And just like learning a new language, understanding API documentation is crucial for using these tools effectively.
Yeah.
So let's get specific. What are some common APIs that developers encounter in the open source AI stack?
When it comes to LLMs,
Yeah.
one of the most widely used is the Hugging Face Transformers API.
Okay.
Hugging Face is a popular platform for hosting and sharing AI models,
Right.
and their Transformers library provides a unified API for working with a wide range of LLMs, including many open source options.
So we don't have to learn a different API for each LLM.
Right.
The Hugging Face API acts as a universal translator, letting us interact with them all in a consistent way.
Precisely. This simplifies the integration of different LLMs into our applications.
Can you give us an example of how we might use the Hugging Face API in practice?
Sure. Let's say we want to use the Llama 2 model for text generation.
Okay.
We can use the Hugging Face API to load the model,
Right.
provide it with some input text or a prompt, and generate new text based on that input.
So the API handles all the behind-the-scenes magic, allowing us to focus on the high-level task of generating text.
Exactly. The Hugging Face API also gives us control over the generation process,
Okay.
allowing us to tweak parameters like temperature and top
Right.
to influence the creativity and diversity of the generated text.
That sounds incredibly powerful. What other APIs are essential for open source AI development?
Well, when working with vector embeddings,
Yeah.
libraries like sentence transformers and SEs offer APIs for creating, manipulating, and searching embeddings.
Sentence transformers, the embedding specialist, and FASS, the vector search engine. It's like having specialized tools for each stage of the embedding workflow.
Exactly. And FAS is incredibly fast and efficient,
Okay.
especially for those large-scale search tasks
Yeah.
where we need to find similar items among millions or even billions of possibilities.
It's like having a team of specialized AI assistants ready to perform their tasks with incredible speed and accuracy.
And the best part is that these assistants are freely available to anyone
Yeah.
thanks to the open source community.
Right.
It's a testament to the power of collaboration and the democratization of AI technology.
This is all so exciting. We've covered a lot of ground today, from data structures and databases to versioning, pre-processing, storage formats, and APIs. It's like we've assembled a comprehensive toolkit for building powerful AI applications with the open source stack.
We have.
Bro.
And with this toolkit in hand,
Yeah.
developers can unlock incredible possibilities
Right.
and build innovative AI applications that benefit both them and the world.
And now for the grand finale.
Okay.
Let's dive into some actual code examples
Right.
and see these concepts in action. All right, let's fire up our code editors and bring these concepts to life.
Yeah.
I'm excited to see how all these pieces fit together.
Let's start with something fundamental.
Okay.
Creating and working with vector embeddings.
Right.
Remember those numerical fingerprints that capture the meaning of text?
Yeah?
They're essential building blocks for many AI applications.
Yeah, those vector embeddings blew my mind. It's fascinating how we can represent complex meanings
Right.
with just arrays of numbers.
It is pretty amazing.
Yeah.
And one of the easiest ways to get started
Okay.
with creating these embeddings is using the Sentence Transformers library.
All right.
It's built on top of the Hugging Face Transformers library, which we talked about earlier,
Great.
and provides a simple API for generating high-quality sentence embeddings.
So no need to reinvent the wheel. We can leverage the power of pre-trained models
Exactly.
and get those embeddings with just a few lines of code.
Exactly. Let me show you a quick example.
Okay.
Let's say we have the sentence, open source AI is changing the world.
A bold statement, but I think we can all agree it's true.
Indeed.
Yeah.
First things first.
Yeah.
You need to install the Sentence Transformers library. You can do that using pip install Sentence Transformers.
All right, so that gives us the library. What's next?
Now let's import the necessary classes
Okay.
and create an instance of a sentence transformer model.
Okay.
We'll use the all-MNet base v2 model for this example Python.
That's right.
Sentence transformers, import sentence transformer model, sentence transformer, all-MNet base v2.
Okay, so we've loaded our model.
Yeah.
Now, how do we actually generate the embedding for our sentence?
Easy peasy. We just call the encode method of the model
Okay.
and pass in our sentence as a string, python.sentence. Open source AI is changing the world. Embedding model.encode sentence.
And that's it. Embedding now holds the numerical vector representing our sentence.
You got it. Embedding will be a NumPy array,
Okay.
a list of numbers representing the sentence's meaning
Right.
in a multidimensional space.
It's mind-boggling how much information can be packed into a simple array.
It is. And these embeddings are incredibly versatile.
Yeah.
You can use them for all sorts of tasks,
Mm-hmm.
from finding similar sentences,
Oh, yeah.
clustering them into groups,
Right.
and even using them as input to other AI models.
It's like having a secret decoder ring for the language of meaning.
That's a great way to put it. Now, let's say you have a whole database of sentences,
Okay.
and you want to find those most similar to a new query sentence.
Right.
How would you approach that using these vector embeddings?
I'm guessing we need a way to efficiently compare our query embedding
Yeah.
against all the embeddings in our database.
Exactly. And that's where libraries like FaceStock come into play.
Right.
ACES is specifically designed for efficient similarity search
Right.
and clustering of vector embeddings.
FaceS. We talked about it earlier. It's like a search engine, specifically built for vectors.
Precisely. Let me walk you through a basic example.
All right.
First, you'll need to install the FASS library
Okay.
if you're running on a CPU. You can use bash, pip, install FaceScope.
Okay.
And if you have a GPU,
Yeah.
you can install the GPU version for even faster performance.
Okay.
Bash, pip install FaceScope.
Okay, so we've got face size ready to go.
All right.
What's next?
Now, let's assume you have a list of sentences
Okay.
and their corresponding embeddings stored in a NumPy array called embeddings.
Okay.
Each row in this array
Right.
represents the embedding for a single sentence.
Got it. So it's like a big table where each row is a sentence.
Yeah.
Each column is a dimension of the embedding.
Exactly. To create a face index for efficient search, we use the following code, Python. Import face, index face.embeddings at embeddings.shape1. Hashtagged create an L2 distance index. Index.add embeddings, add our embeddings to the index.
Okay, so we're creating an index using index flat L2, which uses Euclidean distance to measure similarity,
Right.
and then adding our embeddings to it.
Yep.
Seems pretty straightforward.
It is.
Yeah.
Now, let's say your query sentence is, the power of open source is undeniable.
Okay.
We first need to get the embedding for this
Yeah.
query sentence
Mm-hmm.
using our sentence transformers model,
Right.
just like we did before
Which one?
Python. Query sentence. The power of open source is undeniable. Query embedding, model.encode. Query sentence.
So query embedding now holds the vector representation of our query.
Yeah.
How do we use the FAS index to find similar sentences?
We can use the search method of the index.
Okay.
Like this Python number of nearest neighbors to find. DI equals index.search. NP.array. Query embedding. K vehicle.
All right, so we're searching for the k nearest neighbors.
Mm-hmm.
The top 5 most similar embeddings in this case.
Right.
What are D and I?
D is an array containing the distances
Okay.
between our query embedding
Right.
and the K nearest neighbors found in the index.
Okay.
And I contains the indices of those nearest neighbors,
Right.
corresponding to the rows in our original embeddings array.
So if I want to retrieve the actual sentences, I just use those indices to look them up
Right?
in my original list of sentences.
Exactly. It's as simple as that.
Wow.
You've just built a basic semantic search engine.
Wow, that is incredibly cool. With just a few lines of code,
Yeah.
we've built a system
Mm-hmm.
that can find sentences similar in meaning,
Right.
even if they don't share any of the same words.
And FASS is incredibly efficient.
Right.
So this approach can scale
Okay.
to massive data sets
Yeah.
with millions or even billions of sentences.
This is opening up so many possibilities.
Yeah.
Okay, so we've explored how to create and search vector embeddings.
Mm-hmm.
What about working with the LLMs themselves?
Yeah.
Can you give us a concrete example
Sure.
of how to generate text using an open source LLM?
Absolutely. Let's stick with the Llama 2 model for this example.
Okay,
Make sure you have the Hugging Face Transformers library installed.
I got it installed. What's the next step?
Now we'll import the necessary classes
Okay,
and create instances of the tokenizer and the model itself.
gotcha.
Python, from Transformers, import auto tokenizer, auto model for causal LM, tokenizer, auto tokenizer dash from pre-trained, meta llama llama 27b chat AF. Okay, we're using the llama 27b chat H model from Meta,
Right.
and those auto tokenizer and auto model for causal LM classes
Yeah.
handle the tokenization and model loading. Right.
Precisely. Those classes are incredibly helpful
Okay.
for working with different models and tokenizers.
From the Hugging Face hub, making it a breeze to switch between them.
So convenient. Now, how do we actually use this loaded model to generate text?
Let's use the prompt. The future of open sources.
Okay.
First, we need to tokenize this Python prompt. The future of open source is imputeds. Prompt return tensors pt dot imputeds.
So input IDS now holds the numerical representation of our prompt ready to be fed into the LLM.
Exactly. Now we use the model's generate method
Okay.
to create some new text Python. Output model.generate. Imputeds, max length 50, dose sample true, top K 50, top 0.95, temperature 0.8. Generated text, tokenizer.decode. Output 0, skip special tokens. Print generated text.
All right, we're calling the generate method, giving it our input IDS, and setting the max length to 50 tokens.
Right.
What are those other parameters?
Yeah.
For like, do sample, top K, top P, and temperature doing?
Those parameters control how the model samples from its probability distribution of possible next tokens. Setting do sample to true tells the model to sample from the distribution rather than just picking the most likely token every time.
So that introduces more randomness and creativity into the generated text.
Exactly. Top K and top P further refine the sampling process.
Okay.
Top K limits the sampling to the top K most likely tokens,
Right.
while top P limits it to tokens whose cumulative probability exceeds P. And temperature controls the overall randomness.
Yeah.
Higher temperature, more unexpected outputs.
It's like fine-tuning the creative dials on our AI text generator.
Exactly.
And finally, we use the tokenizer's decode method to translate those generated tokens back into human-readable text.
Precisely. With those few lines of code,
Wow.
you've harnessed the power of Llama 2 to generate text.
This is incredible. It's so easy to get started with open source LLMs.
Yeah.
Thanks to libraries like Hugging Face Transformers.
Yeah.
What other cool things can we do with this library?
The Hugging Face Transformers library is packed with features.
Wow.
You can do everything from text generation and translation to question answering, summarization,
Right.
and even fine-tuning these models on your own data.
It's like having a Swiss Army knife for natural language processing.
That's a great way to put it. And the best part is, this is just the beginning.
Right.
As the open source AI ecosystem continues to grow, we can expect even more amazing tools and applications to emerge.
This deep dive has been an incredible journey.
It has.
We've explored the key components of the open source AI stack,
We have.
from those brainy LLMs and versatile embeddings to the robust databases and powerful APIs that make it all work.
Yeah.
And we've even gotten our hands dirty with some code, seeing firsthand how easy it is to leverage these open source tools to build innovative AI applications.
Absolutely.
Feeling so inspired. This open source movement is truly democratizing AI,
Yeah.
empowering developers from all backgrounds to build the future they envision.
I couldn't agree more. It's an exciting time to be a part of this community,
Yeah.
and I can't wait to see what amazing things we'll create together.
To all our listeners,
Yeah.
we encourage you to join this journey.
Absolutely.
Explore the open source AI world. Experiment with these incredible tools.
Yeah.
And contribute your own unique talents and perspectives.
Right.
The future of AI is collaborative.
Yeah.
And together, we can build something truly extraordinary.
Well said.
And on that note, we'll wrap up this deep dive.
All right.
We hope you've enjoyed exploring the open source AI stack with us and are feeling empowered to start building your own AI adventures.
Yeah.
Until next time, keep learning, keep experimenting, and keep pushing the boundaries of what's possible with open source AI.